Hi, my name is Damara Austin, and I am the Math Aunty. Today, I want to review distribution. Distribution is a topic that comes up in middle school and continues to follow you throughout your mathematical career, through college, so on and so forth. Distribution, as a word, is a noun that means the action of sharing something out among a number of recipients. That definition was pulled from Google. All right, so when you think of distribution, you think of sharing things out. What's being shared when we talk about mathematical distribution? Well, you're sharing the operation multiplication among the neighbors that are inside the parentheses to the number on the outside. So, for example, in 3 times in parentheses x plus 5, I distribute the multiplication of 3 times to the x and to the 5. This is going to end up with an expression 3 times x plus 3 times 5. And 3 times x, because 3 and x are two different types of quantities, it just becomes 3x. And 3 times 5, since they're both numbers, we can do that multiplication. 3 times 5 is 15. So we've distributed the multiplication by 3 across the addition or the recipients, x and 5. One of the key things that I feel makes me a strong teacher, a strong teacher and tutor, is that I have ADHD. One of the beautiful benefits of ADHD is that your mind can think of several different associations at one time. So when I was going over distribution with a student in this past week, I came up with a bunch of different examples and things like that in the moment, and I think I overwhelmed the student, to be honest, but I want to make sure that I share these different associations in whichever way that I can. Let's try a second example. Now we have distribution. We have 2 separate pieces, and we have a variable with a number in front. Again, distribution is the act of sharing among recipients. But the thing to be careful here is that you only share among the recipients that are directly next to you. This 2 is going to be multiplied by this x and this minus 6. It's not going to be multiplied over here by the 2x and the 8 there. Those red lines are not going to happen. In fact, I'm going to erase them. Part of us wants to distribute to everyone, right? You want to distribute to everybody you can. If you've got something good, you want everyone to be able to access it. However, that is not very sustainable for the person that's got the good. So, a better system would be for you to distribute to your direct neighbors. And then eventually everyone is covered because everybody's covering their neighbors. So this 2 is going to be multiplied by x and minus 6. This 3 is going to be multiplied by this 2x and this positive 8. 2 times x is 2x. 2 times negative 6 is minus 12. Plus, now we're doing completely other distribution. 3 times 2x. Well, 3 times 2 is 6, and then x has to stay along for the ride. And then our last product is 3 times 8, which is 24. Now we have this expression. This expression isn't as clean as we can get it. because we can combine like terms. Like terms are terms that have the same variable attached to them in the same amount of powers. You'll see why I specify that on the next example. But here we see that 2x and 6x both have an x attached to them. So we're going to add them because the operation here is addition in front of the 6x. So 2x plus 6x equals 8x's. And then left over, we have minus 12 plus 24. Those don't have a variable attached to them, but they're like terms because they're both numbers. We've been adding numbers for, quite a while. If you've gotten to distribution in your school career, then you should have been adding basic numbers for a while. So negative 12 plus 24, negative 12 plus 24. Well, negative 12 plus 12 will take me to 0, and then there'll be 12 more in the positive direction. So 8x plus 12 is the simplified expression for 2 times x minus 6 plus 3 times 2x plus 8. The key point here was to be careful. You want to distribute only to your neighbors. You only have to worry about your neighbors because everybody else's neighbors is going to distribute to them. All right. In our last example, we throw in 3 things to distribute, a fraction, and we're going to see an exponent. For this last one, because there are 3 different pieces here, I'll do a little color coordination. 3c times 1/3 c minus 3c times 4. All right. For the next product, we have negative 7 times c, and then negative 7 times 1. And for our last product, we have 2 times c plus 2 times 4. All right, for the blue, when we multiply 3c times 1/3 c, multiply the numbers with each other, 3 times 1/3 is 1, and c times c is c squared. C squared, not to be confused with 2c, which is c plus c. Exponents for repeated multiplication, and multiplication for repeated addition. It's a chain of operations. 3c times 4, well, we multiply 3 and 4, we get minus 12c. Negative 7 times c will be negative 7c, and negative 7 times 1 is negative 7. For our last bit, we have plus 2 times c, which is just 2c, and plus 2 times 4, which is 8. Now we're going to combine like terms. Now we see the reason that I brought up earlier, that you don't combine like terms unless they have the same number of the variable. So here, even though 1c squared has a c in it, it has 2 c's because it's c squared. That is not the same type of expression as 12c, which only has 1c. So I'm not going to combine c squared with 12c or 7c or 2c. I will combine negative 12c, negative 7c, and 2c with each other. C squared just stays by itself. 1c squared, we can't do anything with that. Negative 12c minus 7c plus 2c. Negative 12 minus 7 is negative 19. Negative 19 plus 2 is negative 17c. And then negative 7 plus 8. Negative 7 plus 7 will take me to 0. And then there will be one more left over. So there's positive 1 there. This expression simplifies to 1c squared minus 17c plus 1. So we've seen 3 examples of distribution. Mathematical distribution is the action of sharing multiplication across addition or subtraction. Mathematical distribution shares multiplication across addition or subtraction. We had this example where it was one number, one in 2 variables, simple distribution. We had a more complicated example where we did 2 distributions in one expression, with the key point of remembering that you distribute to your direct neighbors. This 2 is going to multiply by this x and negative 6, not by the 2x and the 8 over there. And lastly, we had an example where we had 3 chunks of distribution, emphasizing that you can have fractions popping up. You can have exponents popping up. All of this can all be parts of algebraic distribution. I hope that you learned something from this video. I hope you enjoyed this video, and we'll look forward to catching you next time. You can like my channel, subscribe to my channel. You can follow me on Facebook and Instagram. I'm at Math Aunty on Facebook, Instagram, Twitter, TikTok, and all of those things. I don't use all of those forms of social media just yet, but I do have them reserved. So if you'd like to follow me and wait for that beautiful content to start filling up, you can do so now. And, just get in on this math love. Have a wonderful, wonderful day.